welcome. Today we'll talk about trigonometric ratios. This is the geometry of right-angle triangles. A right-angle triangle is a triangle that contains one 90-degree angle. Now, a trigonometric ratio would be the ratio of any two side lengths in a right-angle triangle. A right-angle triangle. Okay? And as I mentioned before, a right-angle triangle is a triangle that contains a 90-degree angle. So I'll write it for sure. Okay, so why do we want to study the trigonometry of right-angle triangles? Well, there are a lot of special features in right-angle triangles that we're studying that can help us actually measure the other triangles or the rest of the triangles that are out there. And to start with, I am going to draw your attention to this right-angle triangle right here. Now, one angle is 90. That makes these other two angles, angles A and B, together equal 90. So that makes angles A and B what we call acute angles. Acute angles are always less than 90-degree angles, right? Now, that means that the angle C would be the biggest angle in the triangle all the time. And across from the biggest angle in the triangle, more specifically a 90-degree angle, is a side length that we call the hypotenuse. Now, the other two sides will have a special name as well, depending on the angle of reference that we are looking at. And in this case, we'll be looking at the angle A, so I'm marking angle A right here. We're going to say that angle A will always have two arms, just like all angles out there. One of the arms of the acute angles will always be the hypotenuse due to the position in the triangle. And the other arm of the angle is what we call the adjacent, because it's next to the angle. The third side of the triangle is what we call the opposite to angle A. Now, we need to label the sides in this format whenever we are using trigonometric ratios, and we'll understand it better as we proceed. Now, just to keep in mind that the names opposite, adjacent, and hypotenuse are related or connected to the angle that we are discussing or the angle that we are referring to. We call it angle of reference. If the angle of reference changes, for example, in this case, if we looked at the angle B, the hypotenuse will still be called the side BA because it's still opposite angle 90. However, the opposite and adjacent will change places here. So the adjacent will be side BC because it will be the second arm of the angle. And the side AC will be the opposite because it's right across the angle B. As simple as it seems, it's very important that we label the sides correctly. Now, how do we use the side lengths in a triangle, and what do we use them for? We use them to measure the sizes of a triangle. And to measure the sizes of a triangle means that we want to measure the angles and we want to measure the side lengths of triangles. Now, for this, we use the relationship that exists between angles and the side lengths. For example, suppose that you have a triangle. I'm going to try to draw one right here. And in this triangle, we have an acute angle right here. I'll mark it by letter A right here. Now, if I decided to keep the same height for the triangle ABC, so the same height AC, which I'm going to try to do here. But then I decide to change the length of the hypotenuse. That will make the angle A right here bigger. Okay, so the side in here would still be the same as it was before. Okay, but changing the length of the hypotenuse, while of course maintaining always the 90-degree angle, will change the size of an angle. So that makes us think that there is a relationship between the size of the angle and the side lengths in a triangle. There are three trigonometric ratios that we will be looking at. The first one is what we call the sine ratio. The sine ratio is measured, and I will refer to angle A as the ratio of the side opposite over hypotenuse. The cosine ratio is measured as the ratio of adjacent side over the hypotenuse. And last but not least, the tangent ratio. That's the last combination that we haven't actually mentioned. So we just did this over this over this, and now we're going to do the two sides. Okay, so that will be opposite over adjacent. Now, it can be a little bit confusing to remember them the way they are, so for this we use acronyms, and I'm going to highlight in here the letters that we involve in the acronyms. So sine equals opposite over hypotenuse. We call this SOH. Sorry. The cosine, that's letter C right here, is adjacent over hypotenuse. We call this CAH. And last but not least is tangent ratio, so T, and then O, and then A, so TOA. And the whole thing in here is what we call SOHCAHTOA. So let's take another look at trig ratios in the hopes to understanding them a little better. So say that you're given two triangles. They're both right angle triangles. This one a right angle at A, a right angle at T. Okay, and we are going to say that these two triangles are also similar triangles. So what that means is that not only they have one angle 90, but they also have this angle here equal to this, and angle B equals angle E. Now, since the two triangles are similar, then we can write the respective ratios of similar triangles. So I'm sorry, I'm going to delete this. And we're going to say that the ratio of AC over AB, okay, so these two sides, must be the same as FD over DE. Just similar triangle property, right? Now, if we refer to angle B in this triangle and angle E in this triangle, we are trying to write here actually the ratio opposite over adjacent. So opposite over adjacent equals, the same thing applies to angle E, so this will be FD the opposite and DE will be the adjacent. So that's opposite over adjacent as well. So what are we trying to do in here is indicate that the ratio of two pairs of sides in a triangle, no matter how large or how small the triangle is, the ratio of the side opposite over adjacent is still the same. that will give the angle B, which is the same as angle E, a special trait or a special character. So we're going to say no matter how big a triangle we have the angles, in how big a triangle we have the angles B and E, the ratio opposite over adjacent will stay the same. And since here we found opposite over adjacent, remember O and A, means that we are actually measuring the tan ratio. That's the TOA formula. In the same way, we reason about the rest of the triangle. So in the next one, we're going to mark C. That would be the angle marked. And we're going to label the sides as opposite, hypotenuse, and adjacent. So this is the hypotenuse. This is the adjacent. And this will be the opposite. So we're going to say that in triangle DEF, if we were to mark angle F, would have a similar situation. So opposite, this is the hypotenuse, and this is the adjacent. And if you took a ruler and try to measure the ratios opposite over hypotenuse, so opposite over hypotenuse, for each triangle, you would find the same ratio, okay, in both of them. So that would be AB over BC. And this would be DE over FE, where AB over BC and DE over FE are the same in value. The same thing would happen to adjacent over hypotenuse. The adjacent would be AC over BC. And in here would be FD over FE. So these two will also equal each other, and so will these two. And same thing with opposite over adjacent, so which is AB over AC, which is DE over FD. So again, we're going to say these two ratios are equal to each other. Now we call opposite over hypotenuse the sine, opposite over hypotenuse the sine, adjacent over hypotenuse the cosine, and opposite over adjacent the tan ratio. So that's where the name SOH, CAH, and TOA come from. Okay? So now that we know what the ratios are, let's take a look at how we can use them. So if we know the ratio of an angle, we can find the angle. And if we know the value of an angle, we can find the ratio. So first, we're going to start with finding the trig ratio of an angle. So step number one is you want to make sure the calculator is set in degree mode. And you have to type either ratio as and then follow the order. So if you're asked to find sine, you're going to press sine. You're going to press or type the value of the angle and then the equal sign. So I will leave you, and then in some calculators though, you have to go and work the reverse way. For some reasons, not all calculators follow the same order. So you have to press the angle first and then tan and then equal. And sometimes you don't even have to press the equal sign. So again, get to know your calculator. So for example, if I have to find the tangent ratio rounded to 4 decimal places for tan 16, for example, then I'm going to go over my calculator here. So I downloaded this online calculator for free, and I'm going to make sure that I have set my calculator to degree mode first, because if not, then it will be confusing to the calculator. And let me go back in here. So I have to turn it to degree mode. So for the angle right here, it says radian, and I have highlighted degree in blue. So that means that I am good in here. So 10 of 16. So you press 10, you type the angle measurement, and you find the value is 0.2867. And that's what you're going to write in here. So 0.2867. Okay. next question is finding cosine of 40. It's the same thing, so you go press cosine, and then you press 40, close the brackets, and then enter 0.7660. Okay, and in the same fashion, you continue with the rest. I'll do sine 53 as well, and you can do the rest. 0.7986. So 0.7986. Okay, so sometimes if we are given the trig ratio, we can disclose the value of the angle that has this trig ratio. We have to remember that every angle has a unique trig ratio. Okay, so because the ratio of the sides, or a pair of sides in the right angle triangle, will stay the same no matter how big or small the triangle is. So again, when you use this or when you want to answer such questions, converting trig ratios to angles, then you have to make sure the calculator again is set on the degree mode, and then we have to press sine. It looks like a power of -1. The meaning of it is not a power, actually. It indicates that it's an inverse function, so inside-out function. You learn more about them in grade 11, but the way you do this on the calculator is this. So suppose, for example, that you have sine of a 0.7823. So what we do here is you have to activate the button that says sine -1. You probably notice it's somewhere in here, so it's highlighted in red, in black in here, right here. Now I don't need that really, so what I'm going to do is activate sine -1. Whenever a function is given in lighter color, that means that you have to press second function and then that particular button. Notice how sine -1 appeared on my screen, and now it's very hard to get rid of this. So, and now I'm going to press the ratio. So I'm going to type in the ratio. The ratio was 0.7823. So 0.7823. Close the bracket, enter, and I magically now have the answer is 51.47, and I will round it to the nearest 1 decimal. So angle A equals inverse sine. I'm just going to show the work in here. 7823, and that will make, sorry, that's angle B right here, and that will make the angle B, angle A right here, would be equal to, double check again just to make sure, we said that is 51.5. That's what I thought, just wanted to make sure. And don't forget the unit measurements. Let's do one more together. So I'm going to do question C. So the tan ratio of C is 6.8954. So we go second tan 0.6894. So sorry, second tan 0.6894. I press enter, 34.6 degrees. Oh, that's 6.89. Let me double check. Oh, second 10, 6.8952 actually. That's 81.85, so angle C equals inverse tan 6.8954, and that's 89.5 degrees. Okay, so this was today's lesson, and the things that I want you to remember is the number one, the rule of SOHCAHTOA, which we need to use in every problem we solve in this unit, and understanding how for every angle there is a unique value of the ratios of the side lengths in a right angle triangle, no matter the size, what the size of the triangle is, and how to convert angles into trig ratios, so how to find the trig ratio when angle is given, and how to find the angle when the trig ratio is given. That's it for today. Bye for now.